Hello, welcome everyone. My name is Daniel Moyer. I'm a sales support trainer here at Briggs & Stratton Simplified Power. Today what we have for you is harsh environments training. This is going to be a NABCEP accredited course. So if you're looking for those continuing education credits, we're going to have at the end of this presentation, my email is going to pop up. And go ahead and email that email address when you see it and ask for your NABCEP credits. Please spell out your name, your full first and last name, so we're sure to get the name correct on your certificate. Also with me today is Nathan Heston. Nathan, you want to say hello?
Good morning, everybody, and welcome. Good afternoon, depending on where you're from. I'm looking forward to going through the training with you, Daniel.
Yeah, so harsh environments training, I think, is becoming more, thank you, Nathan. I think harsh environments training is becoming more and more important as we see these energy storage systems being installed in other parts of the world that hadn't seen installations before, more northerly climates and also in warmer climates. So we're going to talk a little bit about cold weather, warm weather. We're also going to talk a little bit about using batteries in mobile applications where there's a lot of vibration. So it's really exciting. I see a lot of these batteries being used in mobiles. I know that's not the biggest industry, but I do like to talk a little bit about that. Altitude, we're going to talk a little bit about. And so again, for those of you just kind of jumping on the training, we're going to be giving out our email at the end of this talk to get your NABCEP credits. And also, if you have any questions, put them into the Q&A button. I already see there's a couple coming in right now. So please put your question in the Q&A chat. It's either at the top or the bottom of your screen. So with that, let's go ahead and get started. First, I wanted to talk about all the training opportunities that we do have besides the one that you're on here today. With Briggs & Stratton acquiring Simplified Power, we're now able to leverage the Power Academy. And the Power Academy is an amazing platform. You can learn not only about these energy storage products that we're about to talk about, but also about our generators. Briggs & Stratton has been making engines, these engines for over 115 years. So we have a long history of making power products. And go ahead and jump on briggsandstratton.com /Power Academy. Also, take a look at our simplifiedpower.com website. On there, you're going to find our training calendar as well. And that's where you probably found this talk, and look for some of the upcoming talks. Nathan and I are working on some new talks coming up. Nathan had just done one, I think it was 2 weeks ago, on how to optimize photovoltaics to charge these systems. And I'm going to be coming out with one soon here in early July for how to integrate generators and energy storage systems together. How can generators and energy storage systems complement each other rather than compete? And that's something we've been doing for a long time in the off-grid realm, which is kind of where I got my start. So we're going to jump into a couple slides talking about the history, and then we'll get into some of the topics about extreme environments. Simplified Power has been around, I would say, a relatively long time. Really, you know, and I mentioned this before in another talk, that the first Tesla Powerwall really didn't come online until the mid-2010s, 2015 or so. So the idea that we're taking these energy storage systems and putting them onto grid-tied residential systems that are grid interactive is relatively new. And Simplified Power has been one of the first people in the game. What we were always founded upon, and since the very beginning, is having a safe battery chemistry. And we have talks, and you can find them on our training calendar, where we spend a whole hour just talking about battery chemistry and why the chemistry we use, which is a lithium iron phosphate, which is a cobalt-free chemistry, is the safest of the chemistries. And really, I see a lot of our other competitors moving towards that direction. But we've been the originator of that, and we've also used a form factor, a cylindrical cell form factor, that is inherently safer than, say, the prismatic or pouch cells that other people are using. I got a slide on that coming up. But by being cobalt-free, we're able to avoid that unmitigated thermal runaway. You can still get a thermal runaway in one of our lithium iron phosphate cells, but what happens after it goes into thermal runaway? Does it kind of just put itself out, or does it have that unmitigated runaway where it spreads from cell to cell or battery module to battery module. So we do have UL listings that prove just how safe and effective that chemistry is in our form factor. UL 1642 on the cell level, UL 1973 on the battery module level, and then UL 9540 on the system level. There is the UL 9540A, and that's really the large-scale fire testing. And now it's not a pass-fail test. What that does is just really simulate what it would look like to have a thermal runaway event. And what happens is recorded. Spoiler alert, not much happens in our batteries. But then that helps inform what we call out in our 9540 UL listing. And then also the UL 9540 really looks at when you take different components like an inverter, a battery system, and combine them together, you're not introducing any unforeseen risks that might have otherwise occurred. We're going to talk about these UN Department of Transportation. 3480 is for air shipping and 38.3 is air shipping. We'll talk about those a little bit later. As I mentioned earlier, we're proven. We've been around longer than a lot of our other competitors. So we actually do have batteries that are outliving their warranties. We offer a 10-year unlimited cycle warranty at 100% depth of discharge, which is pretty unique. You know, if you start to look at what happens when you start to put in cycle requirements for the warranty or megawatt hour throughput on the warranty, we let you cycle as many times as you want down to 100% depth of discharge for 10 years. That being said, I do like to see more of an 80% depth of discharge, which is going to give your customer a little bit more longer life at the end of that warranty period. Deployed all around the world, and a lot of batteries are out there. We were tested and validated by the U.S. Army and Marine Corps. And that's one of the kind of the proof in the pudding is that the Department of Defense took our batteries, tested them at the Aberdeen Proving Ground out there on the East Coast in Maryland, and really they liked what they saw. And so that was really an exciting thing for them to have confidence in these lithium-ion batteries, and for us to be proven. And we do also have a business model that shows that profitability and social justice can coexist. You know, the so-called triple bottom line: people, planet, and profit. So if you're somebody out there on this call right now and you have an idea, we call it the IDEA program, and you are having maybe a school in a developing country, or maybe even here in our country or North America. And if you have a clinic or other type of opportunity, email us. My email is going to be at the end of this talk. Email what your idea is, and we can't see if we can't be part of your project, and usually in the form of a donation of batteries. Simple. We've always made an inverter agnostic battery, right? A battery that can pair with other people's equipment. As long as you get into that Outback, that Schneider, that Victron, the Samlex, maybe you got an old Trace inverter, the Xantrex, as long as you adjust the set points in that piece of equipment, the bulk, the float voltages, the low battery disconnect, we can easily and simply integrate into that older piece of equipment, and store that backup power for your customers and give them that resilience and energy security. I'm seeing a lot of opportunities and market drivers with these energy storage systems. A lot of people around the country now are starting to get hit with time of use rates, where during certain times of day, energy is more expensive. The utilities are finding creative ways to charge us more money. Well, we can tell an energy storage system that energy is more expensive during certain times of the day, and the energy storage system can discharge itself, cover your loads, help you from buying that expensive power. Demand charge, I think, is becoming more common on the commercial side. We're seeing it a little bit in residential. That's if at any time during the day you exceed a certain kilowatt threshold in power, the energy storage system can start to discharge itself and shave those peaks off. One thing I'm also seeing, and for those of you here in California, is our new net metering agreements. Under our old net metering 2.0, NEM 2.0, if you export it to the grid during the day, you would get a credit. And you could then use that full credit at night or in the winter And it was then at the end of the year, you'd get a true up bill. Well, with this new net metering 3.0, what's happening is that now during the day, when you export to the grid, really you're only seeing a fraction of a credit issued to you. And then when at night or during the winter, you're having to buy at the full price credit rate. So really, if you have solar and you export it, if you don't use it and you don't store it and you export it, you're really losing that value. So we're going to start to see these energy storage system attachment rates going way up in states and jurisdictions that don't have the more favorable net metering agreements. At the bottom of our screen, I'm going to really quickly run through the products. Those on the far left is our Phi and Amplify batteries. These are 3.8 kilowatt hour batteries, either 48 or 24 volt. We've able to put these into battery cabinets, which is really nice because they have kind of more plug and play integrated bus bars and terminal blocks that let you put it together. I'm really excited about our new energy storage system. And I got a slide coming up on this, but it consists of a 6 kilowatt hybrid inverter, our new 4.98 kilowatt hour battery, and an energy track app. And the app is something I find very important a lot. It's not the old grid off-grid days anymore where we go out and look at the screen of our Xantrax inverter and the homeowner's trying to read you the voltage over the phone. No, we have an app now. Everybody's got an app, and these apps are really important for not only homeowners to see visually what's happening with their systems, but for installers like you that can do fleet management and do remote adjustments of parameters and keep an eye on your homeowner systems. High voltage solutions are becoming more common. I'm not the expert on that, but if you want to email me and I'll get you in touch with somebody that does know about these. These high voltage solutions are being used very commonly in commercial systems. And I'm really excited about the Solarc 30K and the Solarc 60K. These are 3-phase hybrid inverters that need a high voltage battery input. So rather than running our batteries in parallel, we run these batteries in series to build up to that 150 volts battery DC input that those Solarcs might need. So really quickly, the history, we've been around a long time relative to the industry. We were founded in 2010 as Ojai Energy Systems, and we really were able to develop our product line to enter the residential market. And that's when we relaunched as Simplify Power. And really, in the past couple of years, some really exciting developments. We were able to open up a new R&D facility and a new manufacturing facility down in Oxnard, California, which is a town just north of Los Angeles. So we actually assemble the batteries here in the United States. And that gives us an awesome opportunity to maintain great quality control, a pivot when we need to see market changes, and it allows us to integrate our own battery management system that's proprietary and made in the United States. Just a couple of years ago, we were bought by Briggs & Stratton. I'm really excited about the acquisition because it's giving us a name brand recognition that a lot of people in the country recognize. If you're sitting down at a kitchen table with a homeowner trying to sell them an energy storage system, selling them something that they recognize or know, or say, hey, I got a lawnmower that has that same engine. They build trust in that product. So really excited about the acquisition. Briggs & Stratton has been around for a long time. They have a history of innovation and engineering, and we truly have a global footprint. We're one of the only 2 companies in the United States that make both energy storage and generators. So we're going to be able to integrate these systems together and have them work seamlessly with one tech support call, one warranty, one manual. So really excited about the acquisition. I'm definitely going to talk a little bit about our generators. You better believe it. So down there on the bottom left is our 10 kilowatt hour Power Protect. We also make that in a 12 kilowatt hour version. And that's a vertical generator. It's a smaller footprint that's allowing you to put this generator into a smaller yard where you're still meeting the setbacks from your vents and the setbacks from any sort of fence or property line. We do have larger generators. What you're seeing down there on the right is a Power Protect 26K. It's the highest output air-cooled generator in the Americas. So we're really committed to this integration and combining these families together, and a commitment to future technical innovation. talked about the market drivers. You guys all know this. Home is a haven. People are working from home a lot more. That's kind of came out of COVID. Existing infrastructure really hasn't been kept up the way it should be in the past. So power outages are becoming more common and prolonged. Climate-related disasters, hurricanes, ice storms in Texas. As soon as one of these events happens, a couple months go by and we all forget about it. Well, that's why it's always good whenever these disasters strike. Whenever power goes out in my neighborhood, I'm kind of excited about it because my phone starts ringing the next day and people remember that. And so it's an opportunity to get in there and give these people, these homeowners, these business owners, the resilience that they need. We're really seeing the electrification of everything. In new houses here in California, they're not even running gas lines to them. Electric heat pumps are pretty common now. And even if you did want to have a propane tank on the property, with these lot lines being so close, where are you going to put it? Maybe you could dig up the front yard and bury a tank right in there in the ground. There's a lot of opportunities now with the new IRA. One of the most exciting things, and I got to correct my slide down there, it should say 2033, not 2023 there. Sorry about that. You can now take a 30% tax credit on just the battery. You don't no longer need to pair the battery with the energy storage or energy generation like a solar photovoltaic system. So in the past, you'd have to put solar and batteries, you could take 30%. Now you can do just the storage system, 30% off. Of course, there's without a generator or solar, there's no way to recharge the batteries. It's only going to last as long as the batteries have juice in them. But you can take that 30% tax credit as long as the homeowners have that tax appetite. I already talked a little bit about time of use, off-grid, backup power, and that demand response. So I'm going to give Nathan a chance here to talk in a second. And what are we here to talk about? We're here to talk about extreme weather, specifically cold weather, which everybody's kind of forgot about because it's summer and springtime right now. But it's going to be important. Talked a little bit about LFP, lithium iron phosphate, being the safer of all the chemistries, but form factor matters. Cylindrical cells matter. They're able to contain any thermal event that does happen. They have a little vent at the top, and they're giving us better performance. Pouch cells, which you find more commonly in less expensive batteries, can swell and contract during charging cycles. And prismatic cells, there's not a lot wrong with those, but they tend to have a larger cell volume. So Nathan, please explain to us why is it bad to charge a lithium ion or lithium iron phosphate cell below freezing? And keep in mind, everyone watching, that what Nathan's going to describing doesn't hold necessarily true to just our batteries. This is across the board. So Nathan, please.
Yeah, sure, Daniel. I'll mention a couple of things. One, you mentioned form factor here and cylindrical cells, and I just want to point out to people that cylindrical cells are not the cheapest. In fact, they're the most expensive cell to make, but they're also the highest quality due to that just structural nature of a cylinder. I mean, you mentioned a propane tank earlier, and we all know propane tanks come in a cylindrical form factor, right? And they do that because that's the structurally best way to contain pressure. And so unlike the pouch cells, which can easily bulge, and there's a picture of an iPhone pouch cell on the left there that I'm holding that has bubbled out, and that's happened in a phone that I had recently. And the prismatic cells, which can also swell and contract, these decrease the lifetimes of the cells. And so that cylindrical cell is really the best form factor for your cells. It's a little more expensive to manufacture, but you get a lot more lifetime out of that cell, and that durability is why we can offer the best warranty on the market. Daniel, you mentioned why you shouldn't charge LFP cells below freezing, but it's actually the case that you shouldn't charge any lithium ion cells below freezing, and it's the same reason for all of them. So if you look at the right side of your screen, there's kind of a little diagram of what the inside of a battery looks like, and it's overly simplified. It's alternating layers of this metal oxide and graphite. But basically, how a lithium battery works is that the lithium greatly prefers to be in the metal oxide layer. In our case, that's an iron oxide or an iron phosphate. And in the case of cobalt-based chemistries, that can vary, but there are different types, and we're not going to get into the chemistry, but the lithium really prefers to be on the left side in that metal oxide layer. And so when we're charging a battery, what we're doing is we're actually pushing the lithium from the metal oxide layer on the left through the porous separator layer and over to the graphite. Now the electrons can't move through the separator, and so they flow through an external circuit, that's your charger, right? And they meet the lithium ions at the graphite. Now, what happens when it gets really cold is that the lithium ions kind of get stuck in the intercalation process, which means the kind of interlayer process migrating between the graphite layers. And so that process slows down for several reasons. One, the lithium ions aren't really moving as fast, and two, the electrolyte, which is kind of this gel that is throughout the whole battery, it becomes much more viscous, like you could consider molasses getting viscous in cold temperatures. And so because the lithium is having trouble moving into the graphite, we have to slow that process down until we can warm up the battery. Now, Daniel's going to tell you we have an innovative way to warm up our batteries below freezing, but I'm going to let him get to that. But this is true for all lithium batteries, because all of these lithium batteries, until they come out with good solid state replacements, have this electrolyte solution. And so it's that slowing down of getting the lithium into the graphite, which is something Daniel's going to talk about. What do we do in cold temperatures? And this is something, a unique solution that Simplify has for their batteries in cold weather conditions. So hopefully I didn't spend too much time there, Daniel, but we're going to get into how our batteries offer a good solution for cold weather environments.
Yeah, no, Nathan, take as much time as you want. I love your input. Thank you. And let me just ask one more question of you. Can you permanently damage a battery, a lithium ion battery, if we charge it below freezing? And if we do permanently damage it, what's the permanent damage that's caused? We might have lost Nathan, so we'll keep going.
Oh, I'm still here. Sorry about that, Daniel. So in cold temperatures, I'm having trouble seeing my mute button on the screen. So sorry about that. So in cold environments, what ends up happening, because that lithium can't get into the graphite, is that it starts to form these solid lithium deposits. And those, with time, if you continuously try to charge a battery in really cold temperatures, can grow into these branches. And so they grow in much the same way that an icicle grows. And we call these dendrites, which is a word that means branches. And eventually, if those dendrites get big enough, they can actually perforate the porous separator layer and even short circuit the battery. And so that's why you want to be careful not to charge below freezing, or if you do, to use an innovative solution like ours, where we actually can slow that charging rate way down so the battery stays protected, and then use that charging to heat up the battery. So Daniel's going to get into that.
Thank you, Nathan. Yeah, that was great. So one of the ways we talk about, and I talked about this a little bit earlier, we have two versions of our battery. We have a Phi battery and an Amplify battery. Our Phi battery is our standard non-communicating battery, and the Amplify battery has built-in battery management system that has communications capabilities with inverters that can listen or talk to it. So when we're gonna, and I'm gonna get into it, just like Nathan said, is that we can slow the charge rate down. So we have an inverter, we have a charger, we have charge controllers, and if the Amplify battery can actually talk to the inverter and tell that piece of equipment what its internal temperature is, hey, charge controller, hey, inverter, I'm cold, slow down my charge rate in such a way that I don't damage myself. So what Nathan had kind of hinted at earlier is that when we slowly charge a battery, there's internal resistance where we build up that heat. So if you're looking at these products, the Amplify battery is capable of doing that. Whereas the Phi or the non-communicating battery doesn't have the ability to tell a piece of equipment to do a slow charge rate. That way, if you are thinking about doing something in extreme environments, you want to consider using the Amplify battery, or a battery that can talk to the piece of equipment. So if you see these temperature ranges here, you can notice that the Amplify battery, when operated with communications, can operate in kind of more extreme temperatures. And it's really the charging that we're concerned about. The discharging or sitting idle, we can have that more kind of wider window. And it's not like the Phi or the Amplify is better than one another. If you are coming out to an existing site that has an old Outback, has an old Xantrax inverter that can't communicate to begin with, there's no reason to buy the Amplify battery that can talk. And so there are other ways, and we're going to talk about them here in a minute, that if you do have an older piece of equipment and you are using the standard Phi battery, that there are other ways, and they're really battery warming or battery heating pads. So again, this is talking about the communication-based programming. And you see there this chart where the Amplify battery can actually tell a piece of equipment that it's below a certain temperature, and then you can see the corresponding amps that should be pushed to the battery so that you're not damaging it. There are some temperature fault protections where the batteries have built-in 10K thermistors, and at some point it's going to tell that piece of equipment that it's too cold, it's too hot, stop charging me, so we're not going to damage ourselves. I get this a lot too, as there's a lot of, I wish I had one of these, a lake cabin up in Canada or up in the upper New York or something, upstate, we'll just call it. People go there for the summer, they leave, they come back after the winter is over, wherever they may be. And what that means is that these batteries are sitting idle. So I get this question a lot. What I want you to do is I want you to get a good full charge on our batteries before you leave for winter. Turn the battery breakers off on the batteries, and you know that you're going to be okay. These batteries have a very relatively slow discharge rate, about 1% per month. So get them on a full charge, let them sit there, and then when you do come back in summer or springtime, don't turn on the loads, get another full charge on them, and then you should be good to go. The Phi does not have a built-in internal temperature that can talk to a battery management system. So if you are using an older system, make sure that we have ways, and there's third-party applications like Victron makes one, that's going to curtail the charging rate of this battery before you damage it. The Amplify, like I said before, does have the ability to talk and has built-in thermistors that can talk to the piece of equipment and tell to slow down the charge rate. If for whatever reason that charge controller or that inverter is not listening to what the battery's saying, the Amplify battery still can disconnect itself. It still has that intelligent battery management system that's going to open up if it doesn't see something it likes. Already showed you guys this a little bit earlier, but these are our Boss cabinets. These cabinets have a NEMA 3R rated, so you can put these outdoors. Do I want to see you putting them on the south side of the house? No. If that's the only place you can put them on the, or if you're in the southern hemisphere on the north side of the house, right? If you have to, let's create some sort of shade structure. These cabinets do have vents for heat, and I've seen people line these cabinets with insulation for cold weather applications. Keep in mind though that these pieces of equipment, like that Solarc you see in there, and the batteries themselves do create heat themselves. So that just because ambient temperature is a certain temperature doesn't mean that the internal temperature of this battery cabinet or the internal temperature of the battery itself isn't going to be warmer. So what can happen when it gets too cold? We kind of already went out of this a little bit, but you can potentially damage the battery. You're going to get a loss of capacity if you're charging them too fast when it's too cold. And again, I want to illustrate this, is that you see the picture on the right. I mean, look how steep those solar modules are pointed. This has got to be really high latitude, and this has got to be winter, and these modules are kicked way up to catch that sun that's just skirting the horizon in the winter. And that shack, that power shack you see behind these solar modules on this pole mount is most likely insulated, and the batteries themselves have internal heat. So again, just because the ambient temperature is at a certain temperature doesn't mean the internal temperature of the batteries is that cold. And with having built-in thermistors inside of these batteries, we're able to transmit that temperature up. We talked about the reduction of the Amplify. Again, here's the chart showing that the Amplify battery management system does automatically reduce the charge rate based on internal temperature, and it's communicating to compatible inverters to make sure you're not going to void your warranty. Insulation, and I'm going to ask Nathan here. Nathan, get ready for this. Here, I'm going to ask Nathan. We use insulation. There's three ways that we can lose heat, right? Convection, conduction, and radiation. And the question I'm going to ask Nathan here in a minute is, what is probably, if you got these batteries sitting in a metal cabinet, and what mode of heat loss is going to be the greatest to give us damage, or potentially cool the batteries faster? One way to do that is to insulate the battery cabinet. So Nathan, and here's I kind of jumped ahead a little bit. Say we have a metal cabinet sitting out in the outside. How do you expect, what mode of thermal loss do you think is going to be the greatest?
That's a great question, Daniel. And it's kind of a fun question, right? And a lot of us don't think about the radiative process of cooling very often. But radiation really doesn't play too big of a role in cooling until things get fairly hot. So it actually depends on temperature to the fourth power. And so when temperature goes up, the radiative process of cooling, that's cooling by emitting infrared light, right, becomes a very significant factor. And so when you have something very hot, like a molten piece of steel, or even like a fireplace, right, you can feel it from across the room, and that's radiation. Convection is the flow of a fluid where you have molecules or atoms hitting a substance and then carrying the energy away as they move. And typically that process is aided by convective currents where hot fluids rise, right? And so you can see that if you were to look at steam rising off of something or something drying. And then the major one, if you are looking at batteries sitting in a cold cabinet, is actually that conductive process. And so the air in contact with the metal cabinet will cool the cabinet, and then that cold cabinet will, through the metal shelves, suck heat out of those batteries. And so if you want to keep those batteries warmer than the cabinet, simply putting them on some insulation or putting them on one of these heating pads can do that. And you can even put the heating pad on a thin layer of insulation. And to drive this point home, one of the things I've often done with students in the classroom at school is I've said, hey, take an ice cube, set it on a countertop, and take another ice cube and set it on a piece of foam. You'll be amazed at how much quicker the ice cube that's sitting on the countertop will melt. It'll melt in just a couple of minutes. Whereas that one sitting on a piece of foam, next time you unpack an Amazon package, try this. That one that's sitting on the foam will sit there for a very long time, kind of illustrating how much slower of a cooling process or a heating process it is to have something in contact with only air and not have that conduction part of it. So conduction, so interrupt that, as Daniel said, use some foam and separate those batteries from the metal cabinet and racking.
Yeah, and thank you, Nathan. Exactly, and that's what you see in this bottom right picture. We put a kind of a rubber mat down, and then we put the heating pads on top of the insulation. So we're going to try and prevent the metal cabinet from sucking the heat out of the batteries. And then when we do put a heating element in there, we want the heat to not heat the shelf, but to heat the batteries. So thank you, Nathan, for breaking that down for us. There are third-party applications. Remember, I kept talking about how the Amplify battery can tell a piece of equipment not to charge below a certain temperature. But if you have a Phi battery or any battery really that can't communicate, there's other products on the line, and I'm a big Victron fan. Victron makes a charge controller, and when it's paired with one of these battery monitors, that BMV 712, you get a good app. but also what you get is that temperature sensor that you can sandwich in between two batteries, right? So that we can't put the temperature sensor internally, but we can sandwich that thermistor, that temperature sensor in between two batteries. So we're replicating as close as we can to get that that internal temperature. And then the Victron battery monitoring system can talk to the charge controller and curtail the charge rate. I do actually want to go back one slide. If you do have a Phi battery and you are looking to leverage these heating pads, let us know ahead of time, and we can actually integrate these internal temperature sensor, a thermistor, and a relay to turn these pads on when they need to be turned on to keep the battery warm. And this can be installed in the Phi or the Amplify batteries. So that's something, whereas you may not even need one of these battery warming pads at all if you're able to leverage the Amplify battery. Hot temperatures, you know, they are less of a consideration, but again, these batteries can get pretty warm before you start to damage them. And so, you know, similar to cold weather, we can use thermostats to activate different temperature mitigation strategies, like a active cooling system, like a heat pump, or turn on fans. Again, it's important to note that just because the ambient temperature is one level doesn't mean that the internal temperature is the same. I'm actually talking to you from Arcata, California, which is up by Eureka, California, not Arcadia. And I live right next to the ocean. I'm lucky to live up here next to the ocean. I worked at a company called Sunfrost, where we made these refrigerators for a lot of years. And I just stayed up here, but we're right next to the ocean, where we're going to get a lot of humidity, right? That's how redwood trees absorb a lot of moisture. And we also get a lot of sea salt spray. So when you are in a real humid environment, let's make sure that we try to keep them away from condensation and sea salt spray. Nathan, what can happen if we get too much humidity? What can happen inside of a battery?
Well, Daniel, kind of the humidity for a battery is bad in general. There are steel parts in the batteries, and the other problem with humidity, especially when you're close to the ocean, is there's a little bit of salt in the mist in the air, and that, as everybody knows, salt can catalyze oxidation reactions like rusting. And so even though we're kind of using these premium cells, if you expose them to salt vapor long enough, the vents can then rust with time, and, you know, over 10, 20 years, it can damage your batteries. So having them inside a case helps to prevent that. And it helps to, you know, keep those harmful vapors and that moisture away from the cells of the batteries.
Great, thank you. I just noticed, Nathan, we did get a question in, and it's asking about, you know, for off-grid clients and that are needing to leverage these battery warmers, it's important to understand how much energy these battery warmers are going to consume, because they're going to be a parasitic draw on the energy storage system. So I can't just throw out a number to you. I think it's going to be a function of how many warmers you have, how often they have to cycle on and off. So there's going to be some design considerations, but the person asking the question is absolutely correct. You need to account for what the energy of these battery warmers are going to consume in your design. So it may be adding a couple extra solar modules, maybe adding a battery or two. So that's a great question. Nathan.
I'm going to jump in just for a second. So that's an excellent question, right?
Yeah.
And so just like your refrigerator uses a duty cycle, and if you're in a hot environment, your fridge is going to be running much more of the time and consume much more energy. You've got the same kind of thing. But I think what you're asking, you know, really is, how do you account for that? And it depends on how cold the external environment is. But I'm gonna get you a number right now for when the heater is actually on, how much power it's consuming, so you can have a rough idea.
Yeah.
And the nice thing about these heating pads is, because they are integrated into the battery, they're monitoring that temperature when they turn on and off. These heating pads are not running all of the time. And so I'll get you a number here shortly. I'm going to look into the specs for how many watts those use. And Eric came up with another question here. Daniel, do you want to answer that one?
Yeah, can you go ahead and read it for me?
Yeah, I'm going to read it to you. Does the BMS in the amplified line provide an externally available alarm that is a switch closure that would indicate too low, minus 20 degrees Celsius, or less than 70 degrees Celsius for the high side, or greater than 70 degrees Celsius on the high side? This would be very useful for alerting the user of a battery environment beyond useful limits. So do we have any kind of information available from our batteries that goes out?
Yeah, exactly. With the amplified line, we can absolutely do that. You would need a third-party New Sun Road. Makes a device that allows us to look at the internals, a lot of information that's being transmitted out of that amplified battery. And you could integrate something that would allow you to monitor that and look at that. And I got some pictures coming up too. People who just put a thermometer up on top of the battery cabinet.
Well,
Nathan,
before we move on, Eric,
yeah.
I'll just tell you also, I mean, I have one of our gateways and I have one of our systems operating in my garage right now. And one of the things it will tell me is it'll give me an alarm when I'm at too cold of a temperature, too high of a temperature to use my battery. So it depends on the communication software you're using. But as Daniel said, with a New Sun Road gateway, you can get that information and the battery will send that information out. It's monitoring the temperature at 6 different locations. It monitors it on the BMS and it monitors inside the cell packs themselves. And it does send out that alarm, but you have to be able to read it. Yeah. And so our software, our gateway, our inverter can interpret that data. And some others can as well. And Daniel mentions the New Sun Road gateway, because that gateway and its accompanying software package gets you an extreme amount of battery level, module level information, such as temperature, battery health, state of charge of each individual battery you have in a whole bank. And we highly recommend that product.
Yeah, and I highly recommend it for installers. A lot of times I don't necessarily want to share all that data with the homeowners because a lot of times homeowners will fret or worry about stuff that they'll get there. They have all their retired couple and they're just sitting there watching these monitors. So I think it's very useful for installers and certain maybe DIY people. But again, too much information can sometimes lead to service calls that maybe aren't necessary. Altitude, again, we're seeing these batteries and these inverters installed at more extreme environments. And one nice thing about these cylindrical cells that Nathan had talked about, the strength of that cylindrical structure can withstand pressure changes better than, say, a pouch cell or prismatic cells. When you are working at high altitudes, also keep in mind that the inverter itself may also have an altitude limitation to it. So take a look at your spec sheets and make sure you're looking at those specs and not exceeding that. Of course, as you go up in altitude, the temperature drops. So if you are at a high location, most likely you are going to be looking at cold weather as well. I would love to have that Airstream right there. I'm seeing a lot more people with these very powerful off-grid kind of systems in these motorhomes. I'm also living, like I said, I live on kind of the 101 up and down the West Coast, and there's all these people coming through town with these van conversions, these Ford Transits, these Dodge Sprinters, and these are all outfitted with pretty nice, usually Victron. Victron's got a great opportunity with these mobile systems. But what's happening? These batteries are being jostled down the road in these high vibration situations. So keep in mind, we were vetted by the DoD. If you are going to have one of these batteries in a mobile application, put some insulation under it or some padding, right? Just like we're talking about with the heat, that's going to dampen any vibrations. And don't put the batteries right underneath the axles, right? Put it in a different spot of the coach or van or trailer so that you're not going to expose it to as much vibration or reduce it as much as you can. Here's a couple great photos I just wanted to share with you. These are real installations, people. Here's off-grid in Montana, and these are some of our older batteries. You can tell there's some of our older batteries because they still have the black ABS case. I'll show you what the new ones look like here in a second. Look at that insulation. It's a foam box or a wooden box that they put 2 layers of foam. I love that combiner. You can see how they're using conductors of the same gauge and the same length to go up to that combiner. It's a Schneider system there with the DC coupled, it's looking like. They got a nice pole mount. And just to demonstrate how remote some of these systems are, there's a grizzly bear in the person's front yard there. So this is a great installation showing just how insulation can be utilized. Here's another off-grid system. This one's our newer batteries because it has that metal case. You can see that they're combining all of the batteries into one central terminal block. You can see the terminal blocks right here. And then we're feeding into 2 solar arcs that are paralleled up. And you notice there's a heater here. I thought at first this was a dehumidifier, but I'm noticing that there's a yellow gas line here. So this power shack or power area has a heater in it. And then I'm also noticing over here that there is a fan. And I'm sure that this is a thermostatically controlled fan that's venting when it does get hot. Beautiful, beautiful country with a couple of different pole mounts. Look how steep these modules are kicked up to capture that sun that's tracking low in the Alaska sky. Here's a food truck, and I like this food truck. I can't tell if they put any insulation underneath the batteries, but I do like how they put these aluminum brackets to prevent the batteries from shifting. I do like how they have this nice thick aluminum bar that's holding the batteries down. It's an outback system. And I kind of like the idea of how they have modules on the roof, but also the modules are able to slide out on these tracks. So I think these food trucks are awesome. You don't have to be running those generators. Here's some drilling out in Arizona. There's some pole mounts on the right, and then you can on the left, sorry, and then on the right you can see some outback systems. Those look like radians, and there's definitely some outback charge controllers there. But what do you notice? I notice a bunch of insulation, so to keep that inside of that container cool. Talked about it earlier, but we do have an amazing testing R&D facility down in Oxnard, California, where we can simulate a lot of these real world conditions, like that off-grid, on-grid charge discharge. And then we also work with third-party testing labs, like I talked about with our UL testings. So this gives us great opportunity to pivot when needed to keep up with the industry. UN 38.3. This is that test that I was talking about earlier when we had to obtain this on some of our batteries in order to airship these batteries to you. And what this test consists of, if you think about it, it replicates the environment that a battery may see in the cargo hold of an airplane. What happens in the cargo hold of an airplane, right? You get rapid pressure changes, you get rapid temperature changes, and you get a lot of vibration. So we run the batteries through these tests, and if the battery doesn't leak, doesn't vent, doesn't catch fire, we're able to get a certification that allows us to go ahead and put it on our bill of ladings so we can airship these batteries. Additionally, they short circuit the battery to make sure it doesn't get too hot, and then they overcharge the batteries to make sure that it doesn't catch fire. So very important, when we're talking about these airplanes. And I've also heard about certain cell phones being completely banned from flights. And in the news, what you hear about is that a lithium-ion battery fire. What they don't say is that it was a lithium-ion cobalt-based battery that caught fire. And every time I see a news article that says lithium-ion batteries are dangerous, it does a disservice to people like Simplify Power, Briggs & Stratton that are making more expensive batteries on a more expensive chemistry and form factor. And we're just kind of getting lumped all together into this dangerous kind of battery grouping when it's not. UL, so you don't have to believe any of what I just said, right? Because we send the batteries to UL. UL 1642, as I mentioned earlier, is on the cell level. They put it through this regiment of abusive tests. UL 1973 is on the battery module level. And then once we have UL 1973 listed batteries, we can go ahead and integrate them into a system level with a UL 1741 inverter. And really kind of that UL 9540 is making sure that you're not introducing any unforeseen hazards by kind of cobbling together different parts and pieces, like we used to do with our Xantrex and our Morningstar and the like. But further, what we do is we use the UL 9540A, which is a large-scale fire testing that a lot of jurisdictions are now, and utilities are now requiring for interconnection agreements. It's not just a test method, it's just a test method. It's not a certification. So I'm not going to read all this out to you, but really what they do is they force a cell into thermal runaway and watch what happens. And then they replicate those tests at a module level, a unit level, and if you have to, a system level that integrates fire mitigation strategies like sprinklers or built-in fire extinguishers in their batteries, or deflagration radiuses, which are explosion radiuses. So what happens in this test informs the UL 9540 UL certification, what our separation distances may need to be. This how well we do at UL 9540A may allow us to circumnavigate NFPA 855 requirements, saying that you can only have, say, a certain amount of kilowatt hours in one location. Well, we've proven that we can have more than that and not cause an unmitigated fire potential. One thing I do want to talk a little bit about is terminal blocks, and how, if you notice in this picture here, one, it's insulated. That's why I chose this photo. But also, I want to see everybody wire our batteries only in parallel, never in series, and do it in such a way that we're not introducing any extra resistance in the battery wire. So if you notice, these battery cables are kind of looping around here on this closer battery, and this one doesn't have a loop. That's because this installer took the time to make sure all of these conductors were the same gauge and the same length. So you're not getting some batteries working harder than others. And you can see a picture on the right that use a terminal block, use a combiner. A Midnight Solar makes great combiners. So just keep that in mind as we're wiring up. As we're closing out here, I do want to again talk about the Power Academy. It's a great online learning resource for not only our batteries, but for those of you out there looking to become generator dealers, or maybe perhaps are already doing generators. Being part of Briggs & Stratton gives you the opportunity to pair these systems together and know that they've been vetted. There's a QR code there. Go ahead and scan that code, and that'll get you the login, or text LEARN to 33988. Here again, here's the QR code again. There's in-person, where we'll actually come out to your facility and we'll train up your people. We can do live virtual training, kind of like what you're talking about now. There's also self-paced recordings, which I really like. So if you're just sitting there in the evening or at lunch and you can't necessarily make a certain time, go ahead and do a self-paced learning and get you up to speed on anything you may want to know. They work great on desktops and mobile devices. This is just showing you how, if anybody who is not a Briggs & Stratton dealer that's looking to become part of the Power Academy, go ahead and sign up at the Briggs & Stratton /Power Academy. And when you get to this section where it says, please select the group you are most closely associated with, you're not a dealer, you're not a distributor, you're not an authorized installer, go ahead and click Rep Group, and that will allow you to go ahead and create an account without having to have a dealer number. So again, get onto the Power Academy, select Rep Group, enter in your company name, whatever is Solar Johns, and that will allow you to be able to create an account. One thing for you guys installers out there, we'd love to put your company on the maps. If you're here taking this training, that shows me that you're committed to learning, you're committed to being a better installer, and that tells me that I would love you to be one of our IQ installers. We'll put you on the map. There's opportunities to get money back. We also have a photo contest as well. We did have an installer sign-up bonus that has expired. Sorry about that. But we do stay tuned. We do have other installer bonuses and opportunities coming along all the time for that opportunity. There's the QR code to sign up for the qualification program. Otherwise, email me. That's the email. So if anybody here is looking for their NABCEP credits, We can give you the continuing education credits. Email training@simplifypower.com. Send me your full last name, first and last name, and we'll go ahead and issue the credits. If you're looking to become part of the IQ program, email me. I'm excited that you were here learning about training. We'll get you guys signed up.
Great,
It looks
Daniel.
like, yeah,
We've got
Nathan.
about 5 minutes left, and Eduardo has a good question for you. I noticed several DC bus bars / connections. Can you mention several ones adequate for Simplify installations, such as for multiple batteries?
Victron, right? Victron makes a great one. Victron is, I think it's the power in, and that's a great combiner.
He's asking specifically about bus bars, and we do sell a 3-battery bus bar that I currently have on my system at home.
And a 2.
Yep. And then there's an external party we often recommend. Daniel, who is that?
Storm Components.
Good. So Storm Components, and that's referenced, I believe, in our manual, at least for the Amplify battery. You can look in the installation manual to see. So Storm Components makes custom bus bars. And I'm not sure if there are others, but like I said, we sell a 3-battery combiner bus bar. And so check that one out if you're looking to do 3 batteries.
And as we're talking on that subject, say we have 3 batteries and we have a bus bar on the positive. Remember, we're always going in parallel. And then we have a bus bar on the negative. We want to tap off on opposite ends of the battery bank. That way we're making sure that we're not having one battery work harder than others. Earlier, I talked about how I always want to use conductors of the same gauge or the same length going to a common terminal spot. I see a lot back in the old days of us using paralleling up by going positive, positive, positive with wires and negative. So Nathan, why is it that we allow you to use bus bars that kind of daisy chain, I'll call it, up, whereas we don't want you using wires to do that?
Well, it's really just a question of ampacity, Daniel. So there's a couple of things that go into electrical resistance, and one of them is cross-sectional area of the conductor, right? So our bus bars are 1/4 inch thick by 1 inch wide, and so you've got a lot of cross-sectional area there. And then the other is kind of contact resistance. And by doing multiple crimps, multiple connections on those cables, what you end up having is when you're drawing lots of current, and keep in mind, these amplifiers can surge 100 amps, right? That's 5 kilowatts of output power for a single battery. And so they're surging at 100 amps each, right? And that can result in very high currents going through these cables. And when you have that much current going through your battery cable, you do get small voltage drops. And those voltage drops can therefore kind of imbalance the amount of work that each individual battery is doing. And so the ones with the shortest path or the closest connection to the inverter have a little bit more of a drain on them than the batteries kind of in the middle. And that's why Daniel said you want to go off of opposite corners there, because that at least makes the 2 outside batteries completely symmetric, and it minimizes, even when you have 3 batteries, there's just a slight difference on that middle battery taking a little bit less of the loads than the 2 outside batteries. We can do it with bus bars because we have a very low resistance, electrical resistance on the bus bar. But as we start to get into cables, we're talking about more and more resistance. And therefore, we don't recommend daisy chaining with cables. And if you do use cables, we recommend combining them with a combiner and using cables of equal length so each battery is equally stressed.
Thank you. Any more questions, Nathan?
There's one that David is, I think he's making a comment about the UL listing. And so David's asking about CULUS and CETLUS that cover all of North America. But I'm not sure about the certifications. Daniel, can you speak to how UL compares and where it's accepted?
Yeah, so UL 9540 is a North American. It's recognized both by Canada and both by
North
United
American,
States
okay.
as well. And it's huge. A lot of I've heard that UL, and it's not UL created the standard. They are not the only ones that do the testing. There's other Intertech can do them as well. But these UL listings are becoming more common, and a lot of people are coming to market with their batteries. I've heard that UL has actually had to open additional testing labs just to keep up with the amount of people that are looking to pull these UL listings.
Thank you, Daniel, and I appreciate that clarification. And David, I appreciate the question. That's the last question, and actually, we got a quick one. Daryl asks, how much power does the internal heater draw?
That's right.
We just, I just found that information. It's 75 watts when it's running. And that was answered in a previous question as well. So you can go back and look at that. And David just says, thank you. And then one final reminder for everybody. So thank you for your attendance. We really enjoy having you here, and especially getting your questions.
Yeah.
If you're here for that NABCEP certificate and you need that, please send an email to training@simplifypower.com with your name as you want it to appear on your NABCEP certificate. We'll check the attendance logs and we'll issue your certificates. So thank you.
Yeah, thank you, everyone. We'll see you next time. Thank you, Nathan.
Bye.